Hi everyone and welcome back. In this lesson we're going to look at box plots and a measure of variability relative to the mean. So in the last lesson we looked at methods of quantifying the center, and if you'll recall, ways we did that was we looked at the mean and the median. And if you'll remember, we use the mean when the distribution is approximately unimodal and symmetric, and we're going to use the median to describe the center when the distribution is skewed. We also looked at ways to quantify the variability or the spread, and the way we did that was we looked at the range, and we also looked at the quartiles. Specifically, we looked at the inner quartile range, or the IQR. Remember, that's just Q3 minus Q1. And in doing that, we found the 5-number summary. And if you'll remember, the 5-number summary was the min and the max, and then the median, which divides the data into 50%, and then also Q1, which is your first quartile, and Q3, which is your third quartile. So with that 5-number summary, we can create a box plot. Now, we don't have the data for the hair care question in 1.3, so I'm going to provide you with some information here. We're going to pretend that these were the numbers that we found in class. So males and females were to write down the amount of money spent on their haircuts. And let's just say for males, you had the following 5-number summary. And keep in mind, these are all in dollars. And then for females, we had the summary. Okay, so to create our box plot, what we're going to do is we're going to label our number line. So we're going to go from about 30 up to, let's see, our highest number is 50. So let's count by twos. So 40, 50, and so on. Okay, so let's look at males first. All I'm going to do is just put a dot above those 5 numbers. So 34 for males, 38.5, 43. Remember, I'm counting by twos. 45.5 and 50. Okay, so what we do is we put a box around your Q1 and your Q3. And the box, remember, is called the interquartile range. It represents the middle 50% of the data. We put a vertical bar through the median, and then we draw whiskers out to the min and the max. Okay? We're going to do the same thing for females. So this time we're going to start at 31, 32, 37, 41, and 47. Okay, again, we put a box around the first quartile and the third quartile. That's known as the IQR. It's the middle 50% of the data. Put a vertical line through the median, and then we're going to draw whiskers or horizontal lines from the IQR out to the min and the max. So by looking at these box plots, we can determine a center, a shape, and a spread for each, and then compare. So feel free to pause the video and take a look at both graphs and compare the box plots and what do you notice about the box plots. So one of the things that stand out to me is it looks like the males in the class spent more money on haircuts than the females. And the way I know that is by looking at the box plot, right? Men spent the most, with the max being $50, and also they had a median of $43. So that means half of the males in the class spent more than $43, and the other half spent less than $43, as opposed to females, where half spent more than 37 and less than 37. And you can see that females spent an overall median less amount than the males did. Okay, and also females had the lowest minimum between the two genders. Okay, so we're asked to label the box plot above with the name of each number. Okay, so we know we have, and I'll just label the females here. We have min, we have the Q1, we have our median, also known as Q2, we have Q3, the third quartile, and then the max. And keep in mind, each of these pieces is 25%. So the box plot, when you create a box plot, it divides the data into quartiles, or 25% each. Okay, and we also want to remember that we have our box here, which represents the IQR, and the IQR is the middle 50% of the data. And if we're to compare the two IQRs, it appears that the females have a larger IQR than the males. And you could easily tell by subtracting the Q1 value and the Q3 value for both. So here it looks like if I subtract Q3 minus Q1, my IQR is equal to 9, 41 minus 32. And then here, 45.5 minus 38.5 is 7. So the females indeed have the larger IQR, and the larger IQR means there's more variability or more change between those values. The range, remember, is just the max minus the min, and we said that the IQR is your Q3 minus your Q1. Okay, so if we want to compare the variation in the amount spent by the two genders, we want to, when we're looking at variation, we want to look at the IQR. So as we said, the females appear to have a larger variability in prices than males do. And that just means that, you know, females, the prices that they spend on to get their hair done changes a lot more than males, okay? So we're going to say it appears that the hair, we'll say hair cut prices for females has a larger variability than for males. Okay, we know that the females have an IQR of $9 and the males have an IQR of $7. Okay, so how do we know then if we have any outliers? And remember, outliers are just outsiders or extreme values. They're values that are away from the rest of the data, okay? Your book technically says it's a value that's much greater than or less than the rest of the data set. But how do we figure out whether a value is an IQR? We have a couple steps. So we know that the IQR is 7 for males. And what we're going to do is we're going to take 1.5 times the IQR. Okay, so I'm going to pull up my calculator and we're going to do 1.5 times 7, okay, which is 10.5. Okay, so now I'm going to take my Q1 and I'm going to subtract 10.5. So the first quartile for males was 38.5. And now I'm going to subtract 10.5 and you get 28. Okay, and then I'm going to take my third quartile and I'm going to add 10.5. So the third quartile for males was 45.5 plus 10.5, so that comes out to be 56. Okay, so now what we do is we look to see, are there any numbers less than 28 in our data set, in our 5-number summary. Okay, so if we look at males, the lowest number is 34. Okay, and that's okay. We're looking for numbers that are less than 28. Okay, and then I want to see, are there any numbers greater than 56 in the data set for males? So there aren't, right? The highest number there is 50. So there's no outliers for the males. Okay, so if you were thinking maybe this was an outlier because it looked like it was far away, it tends to not be based on our calculations. Okay, so what we want to do, I'll make a little note here, is you want to look to see if any values are less than 28. Okay, if so, they would be considered outliers. Okay, and then I want to look to see if any values are greater than 56. And there's not, right? So it does not appear that there are any outliers. There doesn't appear to be any outliers. Okay, we're going to do the same thing for the females this time. Okay, so you might want to pause the video and practice on your own. So I need the IQR, so that's 9. And we have our quartile 1 is 32, and then 41 for our third quartile. Okay, so we're going to do 9 times 1.5. So that's 13.5. And now I'm going to do Q1, which I think I said was 32, minus 13.5. Okay, and that's 18.5. And then I'm going to do Q3, which is 41, plus 13.5. So that comes out to be 54.5. Okay, now I'm going to look to see, are there any numbers less than 18.5 in my data set? And I don't see any. Are there any numbers that are greater than 54.5 in my data set? Again, I don't see any. The highest is 47. So we don't have any outliers again. Okay, and I'll put a little note here. There are no numbers in the 5-number summary less than 18.5 or greater than 54.5. Okay, So consider those your fences. So if we're taking into account that last problem, the 18.5 would be a fence here, and then the other number, 54.5, would be your other fence. So as long as you don't have any numbers below or less than 18.5 or above or greater than 54.5, then you don't have any outliers. Okay. Sometimes you can create what's called a modified box plot. So the modified box plot is when there is an outlier, and let's say this value, you know, here ended up being an outlier. Okay. We would want to star that off, and we would want to make sure that our whisker only extended to the next highest value in the data set. So we would have to go back to our data set, and whatever the wherever the fence is, right, that would be the next highest value, and that's where the whisker would stop at. Okay, and there's a video in the modules if you care to look at modified box plots, and there's also one in the homework which you should practice. Okay, let's look at another way to quantify variability. So one way is looking at the IQR, the 50%, and also looking to see whether we have any extreme values there. Let's say we have two routes, Route A, okay, and Route B. And these are the two options you have trying to figure out the best route to take to work. And we have, for each route, you kept track of the time that it took you for 5 days. So it took you 11 minutes to get to work using Route A, and then 12 minutes on the second day, 15 on the third, and so on. For Route B, you also kept track of the time. Okay, if we look at a graph, we've got basically two dot plots. So we have a dot plot for Route A, and then a dot plot for Route B. Okay, by looking at it, which route has more variability? Okay, so in other words, was there a travel time for one route that was maybe less consistent than the other? Okay, so pause the video and take a look. And again, which route appears to have more variation in time travel? Okay, so if you're looking at the variability in routes, you'll see that the median for both is 15, okay? And actually, if we were to find the mean really quick for Route A, let's take a look at that. So my mean, or my average, X bar, we would do 11 plus 12, which is 23, plus 15, that's 38, plus 18 is 56, plus 19 is 75, divided by 5 is, what is that, 15, okay? And I'm guessing my average for Route B is going to be the same. So 11 plus 14 is 25, plus 15 is 40, plus 16 plus 19 is, again, 75 divided by 5, so 15. So the average and the median for both data sets is 15. So both of my graphs are going to be symmetric if I was to plot this. And if you look at the dot plots, if I draw a vertical line down the center on both sides for B and A, it's symmetric. Okay, so if you look at the left side, it should look very similar to the right side, if not the same. Okay, so how do I know where there's more variation? Well, if you take a look at Route A, we can see that from the mean, right, we're 4 away and then 3 away. Okay, here we're 3 away and 4 away. Here we're 3 away, but we're 1 away. And we're 1 away here, and then we're 4 away here as well. Okay, so where is there more variation if I'm looking at the time travel? Okay, feel free to pause the video and try answering that on your own. Okay, so route A actually has more variation or variability from the mean, because if you compare the numbers on either side of it, from 12 to 15, it's 3 away, but in route B, it's only 1 away. Okay, and the same is true on either side. Okay, and then as you go to the outer part, it's 4 away. Okay, and it's 4 away here. But because these values are only 1 away from the center, that means that there's less variation or less change. Here, there's greater change between the mean. So, in order to determine a statistic that's used to measure the variation or spread in the data that relates to the mean, we're going to look at something called the standard deviation. And it's based on how much the data values vary from the mean. Okay, so when the center of a data set is described by the mean, the variability will be described by the standard deviation. So the standard deviation and the mean go together. And if you'll recall from the last lesson, when we use the mean to describe the center, we want to then use the standard deviation to describe the spread. When I'm using the median to describe the center, I would use the interquartile range to describe the spread. So how do I find the standard deviation? Or in other words, how the data values vary from the mean. Okay, we have some steps. Okay, so if we take those route travel times, as we calculated, the sample average time for both routes is 15 minutes. Okay, and remember x bar is the sample average. So what I need to do is, if I want to find the standard deviation, an actual number for route A, we can clearly see that route A has a larger variability. Because route B, we have these 2 dots closest to the mean. So that makes the variability smaller when compared to the mean. So we know that A has a larger variability because on average, these dots are further away from the mean. How do I actually find a value? So you need the mean, and the word deviation just means the distance from the mean. So let's take route A. Okay, I've got my values here. The very first step is you're going to take each of them and we're going to subtract the mean. So the first one was done for us. Here we have -3, 0, 3, and 4. Okay, now, if you're paying attention, deviation, like I just said, means it's distance from the mean. And when it's a positive deviation, it means it's above the mean. If we get a negative deviation, it means the data value is below the mean. Okay, like here, 11 is below the average of 15, so it's going to be negative. But if we're dealing with distances, we can't have negatives. So what we do is we take each of those values and we square them to get rid of the negative. So as you can see, I have those values here that we just calculated, the deviations. Now we're going to square all of them, and it's going to turn our deviations positive. So these are known as the square deviations. So if I square -3, I get 9. 0 squared is 0. 3 squared is 9, and 4 squared 16. Okay, what I'm going to do next is I'm going to take those deviations and I'm going to add them up. Okay, so we're going to calculate the sum of the squared deviations. Remember, sigma means sum. So we're adding these right here. Okay, when you add those numbers up, you get 25 plus 25, which is 50. Okay, so the sum of those deviations is 50. Okay. The next thing I'm going to do is I'm going to then divide by n minus 1. So n is your sample size, okay? And my sample size here is 5. There's 5 days that you took the time down. So I'm going to subtract 1 from that. So I'm basically dividing 50 by 5 minus 1, or 4. Okay, so 50 divided by 4 gives us 12.5. Okay, so this is now 12.5. My very last step, and by the way, this value right here is known as the variance. Okay, and in case you're wondering, how is the standard deviation related to the variance, just remember that the standard deviation equals the square root of the variance. Okay, so likewise, if I have the variance and I want to, or if I have the standard deviation and I want to find the variance is just equal to the standard deviation squared. Okay, so that's how they're related. So my last step now, as you can see, is to take the square root of that value. So we're going to take the square root of 12.5 and let's see what we get. So the square root, I have to hit second and then x squared, and it's 12.5, hit enter, you get 3.54. Okay, and standard deviation is measured in the same label as our mean, which was in minutes. So the standard deviation is 3.54 minutes. And the abbreviation for standard deviation is S. So S is 3.54 minutes. And by the way, that's for a sample standard deviation. Okay, the population standard deviation, for population, we always use Greek symbols, so it's the Greek symbol sigma. Okay, and variance is sigma squared, right? If I want to find the variance, I just take the standard deviation and I square it. So these were the steps that we followed, and this is how the formula is created. So the first thing we did was, remember, we found the mean. Then we subtracted each value minus the mean. We squared all of them to remove the negatives. We added all of those numbers. We divided by the sample size minus 1, and then we took the square root of it. So if you break the formula down into steps, it's really not that bad. Okay, and the calculator, of course, will give you the standard deviation without all that work. Okay, so what does this value actually mean? It means on average, it took you 3.54 minutes longer or shorter on using Route A to get to work, okay? So we said earlier, by looking at the dot plot, Route A had more variation. So that means that the standard deviation we just found should be larger than the one that you'll find for Route B. So I'm going to let you calculate Route B on your own, but I'll give you the answer so that you can check your work. You should end up with a standard deviation of 2.9 minutes. So that means that Route A did have more variation in travel time because it was larger. Okay. The last thing is this data set here that it's not a super large data set, but it's large enough where we would want to, find information about it, okay? So luckily, technology will help us compute the mean and the standard deviation. So let's really quick take a look here. Let's say I want to find the mean and the standard deviation for the heights of those buildings, okay, in feet. So what I'm going to do is I'm going to type those numbers in for each of those buildings into my calculator. Okay, so do you remember how to do that from the last video? You're going to go to Stat, which is 2 buttons to the right of the green button, okay, and then click on Edit or Enter. And if you have values in there, you're just going to use the arrow up on top of L1 and just hit Clear, okay, and that will clear those values. Now the first value I'm going to type in, remember I'm finding the average height and the standard deviation of the heights of the 10 tallest buildings. So I'm going to type in the heights in feet, okay, so bear with me here. Remember, every time you type in a value, you're just going to then hit Enter. Okay, and I have 5 more to do. Okay, so there's my 10 values. Let's say I want to find the mean and standard deviation quickly. I'm going to go back to stat, and then I'm going to go to calc. So I'm going to hit the right arrow, and we have one variable here. Our variable is just height. It's one column. So hit enter, and then all you have to do is hit enter again. Make sure the list has the correct column, which was L1, where we typed everything in. Hit enter, and then you have all of the information here that you need. So if you're looking at that list, X bar, remember, is the sample average. So that means the average height of the 10 tallest completed buildings in the world is 1,722 feet. And if I'm looking for the standard deviation, that would be SX. We just label it as S. And the standard deviation would be 385.3 feet. So there is a lot of variability between the heights of those 10 tallest buildings. 385 is a large height. If you look underneath SX, you'll see sigma X. It says 365.6. So that's the population standard deviation. That would be if you followed the same steps, except if you divided by n, or if you divide by 5 instead of dividing by 4, okay? Or rather, in this case, it would be if you divided by 10, since we're dealing with 10 buildings, and then that would give you the sigma X. If you divide by 9, that's where you get SX, because remember, when we're trying to find the sample standard deviation, you always divide by the sample size minus 1. And then if you're interested, the 5-number summary is at the bottom. So if you needed to make a box plot, you could see a box plot of those values there. Okay, but that ends the video. Please be sure to read the wrap up and the summary at the end. And also please make sure you do the homework, which is labeled Take It Home at the end. And there are selected answers at the end of the homework. So please check your answers. And if you have any questions, please feel free to reach out to me. Have a good day, everybody.